Hi everybody, my name is Adi. I am Principal Architect at Redis Labs. I also am our Partner Technology Ambassador. Been at Redis Labs now for almost 4 years. Been using Redis since 2012. And one of my claims to fame at Redis Labs is I initially wrote our tile, our Bosch tile that I'll be showing you all a bit later. And I spend most of my time on an airplane, but when I'm not, this is generally what I'm staring at. So who's familiar with Redis? Raise your hand. Cool, that's awesome. Thank you for coming out here to learn more. Hopefully you're going to learn things about Redis that you didn't already know, or at the very least see how someone who knows absolutely nothing about .NET is able to make a global session store application. So if you're not familiar with it, Redis Enterprise is the commercial grade version of Redis. It offers a lot of additional features, functionality in terms of scale, manageability, so on and so forth. I'm going to go into a bit of detail about how it works, but mainly I'm going to be focusing on our ActiveActive technology and the specifics behind that. So if you've used Redis before, it's probably as a cache, but it's not just a cache. There's a lot of different libraries that implement interesting things on top of Redis. In this demo today, I'm going to be talking about Session Store using SteelToe, but there's also queuing libraries, so on and so forth. So there's all kinds of different modes of using Redis because it's this very flexible memory as a service kind of concept. And using our ActiveActive technology, you can take a library that you're already using and scale it out to a global thing with just pushing a button. You don't have to change any code. And I'm going to show you all that at the end of this. So if you're not familiar with Redis, you're probably familiar with these. These are the data structures you're going to find in any given programming language, right? So these are implemented in Redis as different data structures. You can integrate with them and on top of them. Each one of these is going to have its own associated methods, which is useful when it comes to understanding how the conflict resolution data structures work here in just a second. On top of the memory as a service concept, we implemented this concept called modules. Modules are essentially classes. They allow you to write your own data structures. And what we at Redis Labs have done is take and implemented some really interesting generic ones around search, graph, AI, time series. These are not necessarily going to be like your full-fledged bespoke graph product that you'd find with like a Neo4j or a Mongo, for example. But they are good enough to get you kind of 80% because most of the time you don't need to figure out how to manage a new piece of technology just because you need a little bit of graph or a little bit of search, right? So using these, we implemented our conflict resolution technology, which is implemented only in Enterprise. So everything I've talked to up until this point is a part of open source. Many of the modules that we've created, we have a lighter weight version for open source. But in the Enterprise, you have a couple of additional components that are really, really helpful in terms of scaling and manageability. So the first one is going to be your proxy. So that's aggregating multiple Redises behind a single layer. So from the client perspective, you don't know if you're talking to 1, 5, 10, 100 different Redises on the back end. And that also does a lot of interesting things in managing the connection pooling. So if you've ever looked deep at the way that Redis open source works, it's just a single thread, right? And that event loop actually takes most of its time managing the network stack rather than doing the thing that you need it to do, which is setting and getting your bits in memory. So the proxy component kind of mitigates that, right? It also will multiplex connections together. It's essentially the secret sauce of Redis Enterprise, right? There's also a cluster manager component. That's doing all your typical DBA style tasks, database creation, destruction, failover, monitoring. And then there's a UI tooling, REST API, et cetera, and that's what we've built our integrations with things like PAS, PKS, and all the other platforms that we integrate with. So, yeah, let's move on. So, how does this work with the ActiveActive component? These are going to be your kind of high-level benefits. Essentially, if you're using Redis, you're probably wanting it to be very fast. You want low local latencies, and being able to scale that globally is non-trivial because of consistency. For those of you who haven't done a lot with data, quick intro to CAP theorem. You have consistency, availability, and network partition tolerance. You can pick 2 of 3. And generally, every database in the world is going to be network partition tolerant, and they're going to balance back and forth between consistency and high availability depending on what it's built on. Redis is capable of doing both. If you're not familiar, there's a wait command that allows you to be able to essentially stop that single thread until all of the replication is completed. Obviously, you're sacrificing high availability at this point. But these are the things that we kind of can play with a little bit when it comes to the conflict-free replicated data types, because they allow you to have strong consistency locally and a strong eventual consistency globally, which for the vast majority of applications is sufficient, especially if we're talking about something like a session store. So how does that work? And then the other piece too here is going to be that it can connect multiple different clouds or a hybrid environment of on-prem and cloud, which more and more companies are finding to be incredibly important, right? And the data tier behind that is actually the really hard part. So if you can't synchronize your data on the back end, it doesn't matter how many different places you can deploy. Your user experience is just going to suck, really. So how does that work? The conflict-free replicated data types are based on algorithms. Essentially, a bunch of mathematicians got drunk one night and were like, hey, how do we solve the conflict resolution in data replication? It's really, really stimulating topic. But here's kind of a summary of how each of them works, and I'm going to give you a couple of examples here in just a second. But just to go through them, strings, it's a simple value, last write wins. It's not really any way to infer intent with just a simple string update. But if you have a counter, we're just going to send the deltas across. With hashes, if we're talking about an individual field, it'll be last write wins, but each field is treated differently. So you can modify one field over here, one field over here, and they'll eventually converge to be the same unified data set. Counters, same thing, we're just sending the deltas over. Sets are a little more interesting. We're using unions and intersects to be able to figure out what was added and removed, and I'll show you all that in more detail in a second. And sorted sets are a combination of the counter concept as well as the sets. And the last one, which is lists, which is really the hard one, is around causal consistency, which is a very, very deep topic that I'm going to get into a little bit. But it's one of those things that you could spend like 3 hours on and really just kind of melt your brain on all the math, right? So starting out with counters, because they're the simplest, you can see here we're doing addition, incrementing by 40 in North America, incrementing by 30 in Europe, and then incrementing by 50 in South America. And we're sending those deltas across, and eventually they will all converge to the same value, right? So you don't have to worry about the conflicts there. That one's actually really straightforward. Similar idea with sets, so we're adding in Wonder Woman here, we're adding in Star Wars and Coco in Europe, and then adding in Star Wars in South America, but we only have 3 because we're not needing, we're doing the union to determine that. The more interesting kind of example is what happens if you add and remove at the same time. We default to allowing the add to win. So these are things that you as a developer can learn to understand and program against to be able to get very, very high speeds locally in your application and still have a global data platform that is very, very easy to use. So causal consistency is based on this directed acyclic graph model. It's a very fancy way to say a set of data that you can only traverse in one way. So there's a great kind of diagram that sort of helps to understand, but you can't go backwards, and that's where we get our ability to create the order from the link in the list. And so here's an example that's a little bit clearer. You can see here that if the replication is delayed, that the Apple value at the top is not going to end up at the beginning of the list where it should be. It's going to end up at the end. So using the causal consistency model, we can take that, that graph and figure out that the Apple value is actually the first one because there's no way to get to it if you start anywhere else. And using that model, we're able to do all kinds of stuff. And as I mentioned before, queuing is one of the things that people use Redis a lot for. So being able to also active-active queuing globally with a push of a button and no code changes is another thing you can do here, right? So within PCF, this is the way that our architecture works for ActiveActive, and this is the architecture of the application that I'm going to be showing you here in just a minute. I have global load balancer. This is implemented on top of GCP. That's going to the 2 Go routers, shared domains, singular domain across both. There's a steel toe reference app. I literally know nothing about .NET. I copy-pasted everything out of the docs and deployed this. I changed one value, which was a thing in the HTML, so you could see which foundation the request is hitting. But I'll show you the session can get created in one, be recognized in the other, and vice versa. And all of that happened literally without me knowing anything about what I'm doing, except on how to manage Redis. So with that, let me show you. So I have here our steel toe security demo app. I can refresh it. I get a cookie. My PCF foundations are called Elephant and Jaguar, mainly because I'm the one who maintains them and I like animals. So here we have Elephant. That was where the session was created. We can restart or refresh it. We see it's the same session but being served from Jaguar. Now we can delete the cookie, refresh. See, we have a new session now from Jaguar. Refresh again, that same session's available on Elephant. I can't emphasize enough, I didn't do anything to make that happen. All I did was just create the database with ActiveActive using our service broker. And the other thing too, just to talk about a bit, some of the things that we have available with Pivotal. We have various different tiles. So we have a fully managed tile that runs the cluster inside of BOSH, or inside of the PCF Foundation, or Pivotal Platform Foundation. Sorry, branding change. Takes a couple months to get used to. The other is, of course, just a service broker standalone. So if you want to run your cluster outside of the foundation, you can. In practice, our customers pick about 50-50. The other thing you can do is run multiple clusters within a single foundation as multiple different tiles. And you can configure each one separately. So if I want to, I can set this up in a few different topologies. I can do a complete, every node is talking to every other node cluster in terms of ActiveActive, or I can do a ring pattern. It just depends on what it is that you're trying to do in terms of optimization. Right, so you can just go in and configure, hey, here are all the different clusters. And the really cool thing here too is this all works native inside of PCF. You don't have to do anything external. There's nothing special other than the load balancer at the very, very top. And it's all the pipes just kind of talk together. So yeah, I think that's pretty much it. Any questions? Yes. Exactly. So your session starts on one foundation. It's recognized starts on foundation A, moves to foundation B, is available on foundation B. I killed the cookie to get a new session, and I got a new session from foundation B, and it's valid on foundation A. And yeah, exactly. And all of the conflict resolution is happening in our software, and it's distributing it out there. So I could take this and I can scale it out to 5, 10, 15 different foundations. I don't have that many demo environments set up, but semantically you can very easily.
What's the latency between availability zones?
That depends on your IS. It's not specific to us. It's whatever the latency is plus the local latency for us to process, which is typically a millisecond or less. So our latest benchmark has put us at a 500 million, half a billion ops a second with a millisecond of latency. So we've got a handful of customers, mainly like credit card. So like 2 of the 4 credit card companies, every transaction that you use, every card swipe runs through one of our clusters for fraud detection. And so they're some of the highest volumes. But typically, people are more interested in the high availability aspect of what we do rather than the performance, because most people don't need more than 2 million ops a second. So yeah.
And also,
oh, sorry. No, finish your thought.
No, and also for fraud detection, even if there's a little bit of latency, the use case doesn't.
Yeah, but if you're standing at the store and it takes 10 seconds for your card to get accepted, that's a different problem entirely, right? Like latency, especially in today's age, is hugely important. I know C-level people who have been fired because they can't get their website to load in under 2 seconds. Redis as a cache is oftentimes the answer to that exact problem. But additionally, what you also see is every step in the application stack has its own amount of latency. So if you have everything built on like a monolithic relational database, you're going to see about 150 milliseconds with every call on top of everything else that has to happen, right? So if you're using Redis as an operational database, you can still have SQL as a system of record if that makes you feel more comfortable. But for most of what you need, you can just hit Redis, and then you export that out with an ETL, or you have some kind of secondary stream processing. There's another talk that we're doing tomorrow on the streams data structure. And that's another thing that you could do, is essentially have a consumer that's listening to the stream and you're pushing the write to both. And now you have that. So there's a lot of, as a developer, I really don't like magic. like things that are black boxes obfuscated away from me. Redis is really cool because you don't have that. Everything's kind of out there, and so here, these are the rules of the algorithm. You learn the rules of the algorithm, you get the replication that you expect. Versus, say, another key value store provider out there in the world, which doesn't deal with any kind of consistency problems. If you have two writes to the same key in two different locations, they say, oh, sorry, you have to fix it now, which is not a scalable or viable solution and definitely doesn't get you a zero code change sort of thing. You were first.
Show some of the .NET code that you have.
Yeah. Like I said, I don't really know much about .NET at all. So the only thing that I changed was here. I added this value.
Go to like the startup that.
Yeah. Like I said, this is straight out of the steel toe docs, the demo docs. So if you want to go, I don't have the link in the deck. I'm not sure how, but do you work for Pivotal? Oh, okay, you just got the shirt. Got it. What was your question?
I before use Redis as a cache engine. I'm happy to see the session demo here. My question is, in the session storage, is the data encrypted somehow?
Yes. It's encrypted in the client, is my understanding, because that's one of the things, if you look at the page itself, it says my protected string. So I'm pretty sure that encryption's happening somewhere in the steel toe session library. But like I said, I copy pasted deploy CF push. Like I know this much about .NET, which is a cool thing for this demo, but it makes it difficult for me to answer that implementation question for you.
So you are saying you are using steel toe session management
Yes.
Interface?
Yes. This is straight out of the steel toe docs. Yeah. So
how does things handle the split brain situation?
good question. So at the cluster manager level, you always have to have an odd number of nodes. It's a quorum algorithm. So if we talk about like a 9-node cluster, in the event that you have a network split where you have 6 and 3, the 3 will recognize they're in the minority and they'll shut down all data underneath them. And the other thing too is that if you set up the cluster and you configure availability zones or racks or however you segment your network, we will make sure that a master and a replica for a given database doesn't end up in the same availability zone.
So you don't have any plan doing that like offline support?
What do you mean?
Well, just like you said, you're going to shut down those 3 binary nodes. I have a use case where there was conflict.
I see. If you do the ActiveActive approach, so instead of having one 9-node cluster, you have 3 3-node clusters, you could do that. Because when it comes back online and connects, it will deal with all of the conflicts based on what I was talking about. But you now have a chance where you're going to have different data in your 2 things. So you now have to manage the split brain problem yourself on some dimension, which most people don't want to do, but if that is what your requirements dictate, right? Any other questions? Thanks, y'all. Appreciate the time.
Thank you so much.
Yeah.